from IT department from Ajay Kumar Garg Engineering College. Today I am going to present my topic that is a stack under the basic data structure and algorithm BOE 406. So first we understand what is a stack. A stack is a linear data structure in which items are added or deleted at one end. What is a stack? A stack is a linear data structure in which the item is added or deleted at only the one end. Means if we want to add an item, then there is an at the same place we have to delete that item. For example, of such data structure are a stack of cup, a stack of cafeteria trays, a stack of coins. It is works on the last in first out principle. Mean the item that we have added at the end, this is the first item that we have to delete it on that place. Okay, so yes, stack is work on the principle last in first out. In particular, the last item to the stack is the first item to be removed. Stack are also called piles or push down. So this is a basic stack of cup example. We have to add a cup plate A, B, C, D, E, F. So this is a top of the stack, a stack of cafeteria trays. So first we have to place a one tray, then second tray, then third, fourth, fifth. So this is a stack of tray. So if we want to remove or delete a tray in from this cafeteria tray pile, so first we have to delete this one tray, then this one, and so on. So I want to say that insertion and deletion would be done at only at one end. Insertion and deletion will be done at only at the one end. So yes, stack is work on the principle last in first out. So next is operation on stack. So what are the various operation on stack? First one is a push operation. Push operation is what? When we have to insert a item onto the stack, that this term known as push. Push means it is used to when we are going to insert an element into the stack. This is a push operation. And in the pop is the term to delete an item from the top of the stack. If we want to delete an item from the top of the stack, so element from the stack. Yes. Now, for example, suppose the following 6 elements are pushed order onto the empty stack. These are the 6 elements A, B, C, D, E, F. This means, so this is a stack. For example, this is a stack. First, we have to insert. This is a stack in which we have to. This is an empty stack. This is a empty stack, means there is no item in this stack right now. First we have to insert an element A onto the stack. Then we insert A. After that B, C, D, E and F, so on. So in which insertion can be done only at one end, that is known at the top of the stack. And we also know that in the stack, the insertion deletion is done at only at the one end. So if we want to delete the item F, so we have to remove at that place. If we want to delete an item C, first we have to delete F, then we have to delete E, then we have to delete D, and after that we delete C. We are able to delete C. This means E cannot be deleted before F is deleted, D cannot be deleted before E and F is deleted, and so on. Example, when the elements are inserted in order as A, B, C, D. For example, this is an empty stack. First we have to enter an element, that is A. Then after that we insert an element B. So the top of the stack, so the top point to the top element of the stack, that is B. Now we insert C using the push operation. So now the top point to the C. Now we have to enter D. So top point to the D element. Now we have to delete C. Now the top is pointed at this location. Now if we are going to delete C, after the deletion of C, then the top point B and this one, and if other than we have to delete E. Now the stack is empty. Okay, so as a sum up of a stack is based on the principle last in first out, and insertion and deletion can be done only at one end, that is known as the top of the stack, as we cleared in this example. Now we will take another numerical example to explain the overall concept. Here the stack is size of 4. So now stack is of size 4 means there are only 4 elements, or we can say there are only 4 spaces in which we have to insert an element. More than, we are not going to enter more than 4 elements. So this is a empty stack because the stack size is 4. Then 0, 1, 2, 3, 4 means this stack can accommodate only 4 elements. So the top point at now in the when the stack is empty is point to the -1. When the stack is empty, top is point to -1, and when the element are inserted into the stack, the value of the top is incremented by 1. How? Let's suppose push 10. We have to insert an element 10. So we are going to insert an element, so we use a push operation, that is push 10. So now there are only one element on the stack, that is on the location 0. So the in before the top value is -1, and when we have to insert an element, the value of top is incremented by 1. So the before value is -1, and we have to, if we are going to increase by 1, then the top will be shown at 0. Now push 20. We have to insert an element 20. So we apply a push operation, that is 20. Now top is point to 1. Now push 30, then top is point to 2. Now push 40, top is point to 3, and so on. Another, if we want to enter a element, if we want to insert an element when the stack is full. Now the condition is overflow. If the stack is full and we want to enter the element on the stack, so this will be a condition of overflow. Now in this, if we want to add another element 50, so what will be the condition? Stack is already full and we want to add or insert another element. So this will be a condition of overflow. So at that point, the stack will show a error, or we can say a message, that is a stack is full or a stack is now going to overflow. So there is no element can be added at that point on the stack. Now this will be the condition. Now we apply a pop operation. Pop operation is done only at one end, that is known as the top of the stack. So first we have to delete the element 40. Pop operation, if we are going to delete an element, so we apply a pop operation, pop 40. So the top value is 3, and after that we deleted that element. So the top value is decremented. In the push operation, the top value is incremented by 1, and in the pop operation, the top value is decremented by 1. So in this, the top value is 3. Now if we are going to delete a pop operation, apply on 30, then the top value is 2. Now 1, then this condition. Now if you want to delete an element 10, then top value will be -1. And if there is no element in the stack and then we apply a pop operation on the stack, so this will be a condition of overflow. Means there is no element onto the stack, and if we apply or if we want to delete an element, if there is no element in the stack, then how we can delete an element? So this will show a error message, or we can say a underflow condition. Underflow condition is when there is no element in the stack and we want to and we are going to delete an element from the stack. So this is a condition of underflow. Now this is a array implementation of stack. Algorithm for inserting an element onto the stack. This is an algorithm for inserting an element onto the stack. If we want to insert an element onto the stack, then we have to follow this step as we discussed in earlier slide. Like algorithm push, we are going to insert an element, so start with push the method. Now if top is equal to size minus 1, in this case first we have to check top is equal to size minus 1. Size, the stack size. It can be 4, 5, 6, 10, 100 and so on. If the top value is size minus 1, then write overflow. When, for example, the stack is size of 4. So top is equal to 3. When top is equal to 3, what does that mean? When the top value is equal to 3 and the top point to the value 3 and the stack size is 4, what that mean? Stack is full. So this is a condition of overflow. Then we write overflow. Else, read the item or the data. Read the item that we have to insert. Top is equal to top plus 1. Top key value incremented by 1. Item, we push the item onto the top of the stack and then stop. This is the algorithm to insert an element onto the stack. Now, algorithm to delete an element from the stack. Algorithm pop. First, if top is equal to minus 1. When top is point to the minus 1, then write a stack underflow. Else, stack top item, then we read an item that is on the top of the stack, top minus 1, then we decremented the value of top by minus 1 and then stop. This is a procedure, or this is a algorithm, we can say, to insert or delete an item to and from the stack. Yes. Now, the conversion of infix to reverse Polish notation. For example, we have this expression. So, this is a infix notation. This one is prefix notation because the operator is on the left. And these are the postfix notation of any arithmetic expression. This is infix, in which the operator is between the operand. Prefix, in which the operator is before the or pre the operand, and postfix, in which the operator are after or the post of the operand. So this is a infix notation, this is a prefix notation, and this is a postfix notation. So this is an algorithm to convert the infix notation to the postfix notation, or we can say our reverse Polish notation. Infix to postfix. So the algorithm, this is algorithm to convert the infix to the reverse Polish notation. So first we understand the algorithm, then comes to the numerical part. Yes. Initialize an empty stack. First we have to initialize that our stack is empty. There is no value onto the stack. Repeat the following step. Repeat the following step until the end of the infix expression. Repeat the following step until we reached at the end of the infix expression. First, there are only 3 conditions. First, when the, now get next input token. In the arithmetic expression, there will be an operator, there will be an operand, there will be a constant, there will be a variable, there can be a left parenthesis, there can be a right parenthesis in the infix expression. So get input token, which can any be constant, variable, operator, left parenthesis, right parenthesis. So what we can do, if one of these operator, operand, parenthesis encountered, if the token is the elements of the infix expression, a left parenthesis. If we encountered a left parenthesis, push it onto the stack. Okay, we have to convert a infix expression into the postfix expression. So if the left parenthesis is encountered in the arithmetic expression, we simply put it onto the stack. No other anything needed. A right parenthesis. When the right parenthesis is encountered in the arithmetic expression, what we can do? Pop and display. Pop matlab remove karna and display show karna. Pop and display stack elements until a left parenthesis is on the top of the stack. When our right parenthesis is encountered, we pop, we delete and display all the stack element until the left parenthesis is encountered or the left parenthesis is on the top of the stack. Pop the left parenthesis also, and after that we pop the left parenthesis also, but do not display it. Display only the stack element. Left parenthesis will not be displayed onto the stack. Okay. Now, if an operator is encountered, while the stack is non-empty and token has a lower or equal priority than the stack top element, pop and display. While the stack is non-empty, जब तक कि आपका स्टैक नॉन एम्प्टी की कंडीशन में नहीं रीच करता and the token has a lower or equal priority, then there will be a priority. Plus, minus, divide, addition, subtraction, multiplication, exponentiation, they have different level of priority. Addition and subtraction at the same priority, multiplication and division at the same priority, and the exponentiation has higher priority. So depending upon the lower or equal priority, we do the following step and then pop and display. Now push token onto the stack. After that, when an operand is encountered, just display it. No other function or we can say a value is needed. When the end of the infix expression is reached, when we have to reach the infix expression, pop and display stack item until the stack is empty. So now first we have to consider an example for this algorithm so that it will thoroughly explain. Now this is a arithmetic expression which we have to convert into infix into postfix, or we can say infix into reverse Polish notation. So the expression is A multiply left parenthesis B plus C multiply D plus E. So this will be the expression that is shown in the infix expression and we have to convert into the reverse Polish notation or a postfix notation. So first we have to construct a 4 column. In the first column we show a serial number or we can say the element count. In the second, current symbol as the elements are encountered on the expression we have to write in this column. Then operator is stack and after that the postfix expression. So in this expression first we encountered, we start from the left to the right. First, the element A is encountered. So, according to the algorithm, if an operand is encountered, A, B, C, D are operand, addition, subtraction, multiplication, division are the operators, and left and right parenthesis and have other. So when an operand is encountered, what we have to do? Just display it. So we just display the operand. Okay. Next is multiplication sign. This is a operand. This will be a operator. So while the stack is non-empty and token has a lower equal priority, stack top element, pop and display. Push token onto the stack, because there is push token onto the stack. So in this we have no other the operand and operator. So initially just we put this multiplication or this operator just onto the stack. Now the left parenthesis encountered. Left parenthesis encountered. What will we do when the left parenthesis is encountered? Just push it onto the stack. We push this left parenthesis onto the stack. No changes occur right now. Now B, next element is B. So when the operand is encountered, we just display that element. So we just display the element, that is B. Now plus, addition sign. When an operator is encountered, we push it onto the operator stack. This will be the position. Now C, another operand is encountered, we just display now multiplication sign. Multiplication sign now comes to that this. While the stack is non-empty and token has a lower or equal priority than stack top element. Now the stack top element is plus, addition, and multiplication has higher priority than addition or subtraction. Token has a lower or equal priority than stack top element. So there will be no changes in this, because multiplication is higher priority. Then multiplication is simply put just on the operator stack. Now D just on display on the postfix expression. Now the right parenthesis is encountered. When the right parenthesis is encountered, pop and display stack element until a left parenthesis is on the top of the stack. Now the right parenthesis is pop and display stack element. Stack mein what are the elements? Multiplication and addition. Where we have to stop? When the left parenthesis is encountered. Then multiplication is on the postfix expression, addition is on the postfix expression. After that, we pop the left parenthesis on the also, but we are not going to display it. So in this, the left is also pop from the stack, but not display on the postfix expression. Now plus, just simply plus. Okay. Now the token is plus, has a lower or equal priority, because addition has a lower priority than the stack top element, which will be a multiplication. Then what will we do? Pop the top of the stack element and display it on the pop and display. So multiplication is pop on the stack and display here. Okay. Now the last E. E is an operand, so E will be put at this point. Now the plus is on the operator stack, so this will be at the end of the E. So this is a conversion of infix to postfix form using a stack. So this is a procedure and this is an algorithm that we have to use to convert a infix expression into postfix expression using a stack. I think this will be clear to you all. Thank you so much.